Good morning, everyone. Welcome back to the Daily Grind. This is a machine shop and machine shop culture podcast centered around an informal chat over a cup of coffee. And today, if you guys saw my LinkedIn post, it is another cup of Spirit of 76 by Black Rifle Coffee Company. And being at Lafayette College, it is a perfect mend of the patriotic theme. Speaking of Lafayette College, if you or someone you know has a high schooler looking for a place to put them ahead of the pack when it comes to getting work, Lafayette boasts an unrivaled engineering curriculum, whether it be mechanical, civil, chemical, electrical, or environmental. Our curriculum is by far the tops. We are one of the only schools that puts the students in the place to actually get the experience they need to be able to properly design parts to get everybody else ahead of everybody else. So if you have a high schooler or know somebody looking for a place to send their student, why not say Cur Non, or why not, and join us here at Lafayette. Today is episode 10. We are, I think I named it Hard Hitters Bring Home the Bacon. And we have with us a John McKeever of Sandvik Coromant. Did I say that properly? Sandvik Coromant?
Yes. Good morning, everybody. You said it properly. How are we all doing?
So, John, first thing I like to do with all my guests is, hey, please, a brief backstory. Who are you? Your title with your company, and what do you do for them?
You betcha. You betcha. So my name's John McKeever. I've been in machining since probably about the mid-'90s. I started out as an operator, worked my way into programming, got into a bunch of aerospace jobs and mold making jobs as a programmer. It was about 10 years ago I got signed up with Sandvik, started out as a salesman in the Southern California market. After that, about 5 years into that, I took a position as their rotating indexable specialist for the Western United States. In that position, we flew around, the Western U.S., helped our salesmen, helped our customers with new projects and optimizing processes. And now currently I'm in a new role that is called Advanced Production Specialist that covers Sales Area Americas. So that's both North and South America. And in this role, I'll be continuing on that journey, basically, helping out with the most advanced solutions that we can come to the table with, helping our customers, get that productivity, get that sustainability, get that tool life, get those finish requirements, all of that stuff. With the advanced production position, there's probably an emphasis on harder to do processes, harder to machine materials like what we'll be talking about today, heat treated materials, but also with a big focus on what we call in the industry HRSA materials, heat resistant superalloys. That could be high nickel content, titanium, cobalt, and also with a high emphasis on like aerospace and space type components. So that's currently what we're looking at there.
Wow. So as a reference to the magazine, to all those who read Cutting Tool Engineering, they actually had, I forget exactly which issue it was, but it was a whole issue on machining heat-resistant superalloys. And Sandvik had a couple of pages in there.
Yeah. I'm not surprised.
Some Sandvik tools here at Lafayette. So for those of you that aren't aware, I am a prototype machinist with Lafayette College. We take student and professor ideas and bring them to life as best we can. We also show them where their designs may not be up to snuff. But if you guys notice, I was talking to John before the show started. We are back in the Lafayette EV garage. To me, it'll always be known as the Motorsports Garage, but behind me is the frame of the current car. So big shout out and big thank you to Ben Franco, Maria Romashenko, John Doyle, and I had one more, but Bram Halpert and the rest of the team. Thank you for making the garage available. So now for John, who is Sandvik Coromant? What is their bread and butter, and what is their specialty that makes them the people to go to?
Yeah. Well, everybody thinks of Sandvik kind of like as a cutting tool manufacturer, which we definitely are, and we're really good at that. But we're actually a lot more than that as well. It's helpful almost in a way to think of Sandvik as like an engineering firm. We're besides the cutting tools, we're bringing the most advanced tools, the most advanced techniques. We've got programmers, we've got engineers, we look at the whole thing. We look at the way that the workpiece is being held. We look at the machine and its requirements and all of that. So that's a big part of what we are. As we move into the future, we're incorporating more of a, digital element to our manufacturing world. It's no secret, that the digital aspect of everything is making a big imprint on our futures. So we want to be a part of that. As such, we've got embedded technology in some of our tools already. This is really exciting stuff. Think of an embedded technology like this, where we place a sensor, say underneath an insert, maybe in a boring bar or some other type of tool. And what that sensor is doing is it's measuring real time, vibrations and heat, and it can have a real time effect that communicates with the machine even, and it'll go and adjust, surface footage parameters, feed per tooth parameters, to mitigate those vibrations, to mitigate that heat, to provide a decrease in cycle times. In some cases, it can sense when it's cutting air, and it can do it so fast that it can use time to wrap it during that travel. And then as it engages the material, it's quick enough to slow down and get right into the cutting parameters. So it eliminates waste. It's more sustainable. We get more life out of our tools, and we provide better results to our customers, better finishes, better productivity, lower their costs, lower their energy consumption. Stuff like that is, when you think about Sandvik, that's really what we're looking at, is the whole entire thing. Tooling is a big part of that, but we want to bring everything to the table and make it a really good solution for our customers.
So a question just popped up in my mind, if I may. You mentioned that you do the embedded chips that alter the cutting parameters on the fly. So have you? And one of the big things we talk about, both on the show and the head honchos at the magazine talk about, is Industry 4.0 and the industrial internet.
Yep.
Would you consider this part of that? Would you consider this part of, like I said, Industry 4.0 or AI on the fly?
100%. Yeah, absolutely. And it's there's so much to that. We've been talking about Industry 4.0 since I joined Sandvik over 10 years ago. So it's definitely on our map, and it's something that we're looking at, and it goes beyond even the embedded technology. We're incorporated into a lot of the CAD CAM packages as well nowadays, where we, like, say for instance, we have our what we call Coro Guide, and that's where it's basically a whole entire tool library. And you can import these tool assemblies in directly from our website with the cutting parameters for the type of application that you're cutting, and your CAD/CAM system will just take that and run with it. So there's many different fronts that we're incorporating these digital technologies on, and those are just to name a few.
And is this something you offer to clients and customers? Can they propose a project or a part to Sandvik and to your engineering firm? And do you sell them this solution?
Absolutely, yeah. We've done that in the past as well. We do that currently as well. We have what we call our project engineering team, and for certain opportunities, we can definitely take a look at that. We can even do this with ITAR related components. For those who aren't aware, that's international trafficking in arms. So for sensitive components, we have a secure way where we can relay this information to our engineering team. They can help conceptualize fixtures. They can conceptualize what type of machinery you even need if you're not certain at that point. We can provide tool lists. We can provide models. We can provide the programs. We can provide the tools and the custom tools for that whole engineering thing. And at the end of the day, we even will provide the support to run it off. So absolutely, those are things that we pride ourselves on being able to do. It's with Sandvik, it's way more than a tool.
Wow. And this is excellent. I realize this is not exactly everything we talked about before, but these things pop up on the fly, and I have to get this out for you. So you and I talked. You have a small presentation that I'm really amped to have on the show.
Yeah, yeah. Let's start with that. So, I prepared a little bit for this cast here. We wanted to talk about hard machining. So, there's nothing harder than hardened steel. And so, what we're going to do is we're going to talk about some hardened steel applications and go over what makes them successful and what makes them challenging. So, without further ado, we'll just go ahead and get started. You can see my presentation slide up here.
Yep.
So we'll move over here. So hardened steel, one of the good things about hardened steel is that it's actually one of the smaller groups. We separate materials into material group classifications. ISO P is your steel, ISO M is stainless. This happens to fall under ISO H under hardened. It's where we see it in the industry is a lot of automotive. Actually, we see it with turning, we see it with milling as well. Specifically with turning, we see it with axle shafts. So we have a really good opportunity here to lower customers' costs with processing. A lot of times, axle shafts will go out for a grind operation. You maybe produce a ton of them, and then they get batched. They all go out as a batch to get ground. They maybe come back with some quality defects. You've lost control of that process. You've got a big obstacle in your workflow. Sometimes we can use a hard part turning application where we can completely eliminate a grinding operation. We can hold the surface finishes. We can hold the tolerances. And it all happens right there in your shop. So I wanted to point that out. Beyond automotive components, we see it a lot in mold and die, those require heat-treated materials just for their durability, basically. Fuel supply pumps, stuff like that. So, but the important thing when we start talking about these hardened materials is what are you going to cut them with, right? We have several options. Carbide works. Typically, let me just state too, when we talk about a heat-treated material where we classify it in that H material group, we're typically talking about 50 Rockwell plus. So anything below 50, we kind of treat it like just normal machining at that point. Carbide's fine. When we get above 50, we want to start being really careful. We want to start really looking at not only just what type of cutting tool material we're using, but what is the geometry of that tool. It's really important for cutting materials to have a high hardenability or a high wear resistance. And the way that we do that actually is through the composition of the cutting tool material. And it's really simple. It's tungsten carbide versus how much cobalt is in that mixture. Basically, the more tungsten carbide there is, the higher the wear resistance is, the more heat that tool can take without suffering what we call plastic deformation. And that's basically when the substrate melts, the tool loses its shape. It's no longer sharp. It didn't break. It didn't chip. It didn't wear out. It just melted kind of and lost its shape. And that happens when there's too much cobalt in the mix. So we're looking for high tungsten carbide mixtures. There is something of a, kind of an offset there, right? The higher tungsten carbide you have, the less cobalt you have, you lose. The opposite is toughness. You lose that toughness. So if there's any interrupted cuts or any instabilities in the process, with a high hardness insert, you really risk chipping it out, breaking it, fracturing it, because they're just so much more brittle. So that kind of moves us into the next segment: what makes heat-treated machining successful? And what I can tell you is to mitigate those shocks, to mitigate that, we like to run them high speed, light cutting parameters, so light and fast. Really light chip loads will help avoid that shock that wants to fracture those instruments. So light radial engagements, light feed per tooth. We get away with a little bit higher RPM. As you use a lighter radial engagement, think about a 20% radial engagement on a milling cutter. You've got the tool is entering cut for a very small portion of that circle as it travels around the spindle, and then the rest of the time it's cooling off. So we can actually increase the surface footage to get that productivity up. The sharp edges, it sounds counterintuitive, right? A sharp edge against a really hard surface, it sounds like a disaster, but because of the light application, it's really important to emphasize that light application is what's preventing the excessive shock on that edge. And the sharp edge is actually what reduces the heat that's generated while cutting. So we like to talk about those. Some of the other things besides carbide is actually CBN, cubic boron nitride inserts. That's a man-made diamond. Basically, we press those out of that man-made diamond material. It's very, very hard, very, very wear resistant. It's very susceptible to shock. So again, light and fast. But that's the type of material we use when we want to emit like a grinding operation on a shaft, or we want to hold a really high precision finish on a milling face or something. We can use CBN for that. And then also, I don't want to leave out that we have ceramics as well. Ceramics are often used for treated materials, whether they're chilled cast irons or something else. A lot of the cobalt heat treated materials with high cobalt content will use ceramics as well to do that. So that's talking a little bit about the materials that we use and some of the characteristics that we like to see with that material. Moving onward from that, we talked about how important it is to have that sharp edge, but also how important it is to really feed that lightly. And let's just say that, well, we've got to do a slot, So if you were putting an end mill through a piece of regular ISO P, maybe 1018, you could theoretically full slot that. You're not going to have too many difficulties. It might not be the best way to do it still, but you could get through it, right? If you try that in this heat treated material, you're going to generate way, way, way too much heat. It's gonna work hard in the material. You'll have almost instant tool failure. So we want to really emphasize that light cutting action, and that could be done by using tricoidal type strategies, stuff like that. But always remember light radial, light feed, higher speeds, and let there be room for the chips to get out. Let there be room for the tool to actually traverse that profile instead of just full on bury into it, where that heat's going to become a really big issue. Some other points that are really important is it also sounds counterintuitive, right? With all this heat we're generating, but you'll probably find better results if you turn the air blast on. Whether that's through the spindle or through surrounding the area, you want to have that. It's a much more controlled temperature regulation. If you think about it this way, think of the heat that's generated when you're cutting this material. You've got that cutting edge. It enters into the cut. It instantly goes up to probably around 2,000 degrees Fahrenheit, and then it comes out of cut, and then you've got coolant bringing it right back down to ambient temperature. And now, depending on your RPM, think about how many times that happens per second, and it's a lot. And this is what really it tears apart that carbide mixture that we're talking about. And so what we found is by running air, it allows the tool gets hot, but it's regulated. And it stays at a constant temperature. It avoids the thermal cracking that we see along the cutting edge. Once that thermal cracking starts, you really start to deteriorate the cutting edge right away. And in these types of materials, you've got to have that sharp edge to keep the heat down. So it's like a runaway train at that point if you're not controlling it. So try it with the coolant off. Everybody feels a little anxious about that, but as long as you've got that light radial engagement, those lighter feeds, you're going to be good, and you're going to see a difference. You'll see a big difference. So wanted to talk about that. And moving right on along here, we're talking about the heat-treated materials. This comes straight from the back of our catalog, and this is the H material group, basically. And this breaks them down into the different types. So we have our extra hard steels. There's a few different types of those for sure. And here's kind of the associated hardness level. So again, when we talk about H materials, we're not talking about anything under 50 Rockwell. We've got chilled cast irons. They can get up pretty hard. In fact, we say 55 in our book. I've seen even higher than that. I've seen them 60. We have the stellites, which is the H3 group. Again, these are part of your HRSA groups, but they get heat treated to really high to really high hardnesses. And then last here we've sintered materials, which is like powders that get put in an oven, they get cooked, they become a solid component, and they're very hard. At 67 Rockwell, that's super hard. So yeah, right. So those are kind of what to be. This is what we're looking at when we're talking about that kind of stuff. And then moving right along, we'll talk a little bit about the cutting tool materials just to finalize it. This is kind of just what they look like, right? Carbide, again, will do the trick in most cases. It might have to run pretty slow to get it done. If we're cutting, turning versus milling, the SFM values can change quite a bit because with turning, you've got constant engagement. Milling, you have intermittent engagement. Allows for stuff to cool down a little bit. But, when we're talking about 50 plus Rockwell with carbide, we're, depending on the grade that we're going to use, we're probably around 150 to 250 surface feet, which is pretty slow. If you see these, like these ceramic button inserts, or this is a CBN flake insert. I don't know. Maybe you can see where I'm pointing, but
yes,
those can run 4 or 5 times faster on SFM. So they're great productivity boosters. They can help you throughput a lot more product through your shop, basically, and be more competitive in this environment that we live in every day. It's all about providing, everybody's got a customer, and it's all about providing your customer with the best value. That's how we look at it with our customers, and we know that's how our customers look at it with their customers. And we just see it as a eventual chain of synergies that we can help be a part of that. And we're always excited to be a part of that. So that's kind of the rundown of my heat treated machining spiel here. Yeah.
So I've been writing things down as you've been talking. So and we talked at length on a video call before we had the show, and I got a lot of my questions answered. But in your presentation here, your catalog page, it has the HRC levels. Is that something that could cross-reference to, say, the machinery's handbook or like the carpenter's steel book?
I think it would be. There might be a little bit of an extra challenge here to decipher our MC code versus some of the other codes out there. I do believe this has become an industry standard now.
Okay.
It sounds funny. I haven't opened up a machinery handbook in quite a while.
I live by my thumbs through so many pages. I've worn out some
Sure.
corners.
Well, I found when I was a programmer, I had it at the ready all the time, But in this world, it's a little bit different. We have a lot of our own internal resources that we use as well. So I'm sure there is probably some type of transferability or some translation of those as well. But I'll also offer up here too. If you have a Sandvik rep in your area, if he makes regular stops, or if you have his phone number or her phone number, don't be afraid to reach out. We can always be of support. We can always get other, like what I've done in the past too, as a salesperson myself, is I've brought in our specialists to help our customers out as well. So any questions, always feel free to call up your Sandvik rep for sure.
Now, John, you're on the West Coast. Yes, you're in California?
I'm in Utah specifically, but yeah, I do a lot of stuff here on the West Coast for sure.
So is that your territory, or as you said, you had Sandvik reps East Coast, Midwest?
We got them throughout the country, throughout North America. In fact, I used to know the number of how many reps we had in North America, but it's several hundred. So typically, there's going to be at least a couple of guys that are somewhere near you at least within a few hours. Now, if you're in a big metropolitan area, you'll have guys that are very accessible. If you're maybe in the middle of Nebraska, you might have to schedule something and have a guy come out and visit you.
So here in Easton, we are less than an hour from Philadelphia. So that be pretty quick.
I think there's plenty of people that support your area that are on standby. Absolutely. You betcha.
So you and I also talked about cutting tool development. So you had spoken that you have customer solutions and you have embedded technology. But I believe I shared with you, I wrote an article. Now, it was for tapping, but cutting aluminum is all the same. Some people consider that stuff to be too easy to cut and run into a lot of pitfalls fast. So does Sandvik have any solutions, or have you been developing any cutting tools we can start with aluminum on one end of the scale and the really tough stuff that you've got into in your presentation. But is there something that you've been developing now that you can share with the audience for a range of materials?
We could probably talk for hours about this, actually. I mean, we're constantly developing stuff, but I'm going to focus on, of course, with aluminum, we have solutions for that as well. We do have advanced solutions. We like to use what's called PCD, polycrystalline diamond tooling on that type of material. For one, it lasts really long, and for two, it's way fast too, and it provides superior finishes. But on top of that, what we've seen in the world, what we see moving forward is ISO M and S is huge, and it's becoming bigger and bigger every year. And again, as a reminder, ISO M is your stainless steels, which is a huge material group. It can cover many different types of stainlesses, and then your ISO S's is your super alloys like Inconel, titaniums, Haspalloys, Waspalloys, stuff like that. And so we put a real push on developing our tooling technology to basically improve everything that's around that, because we see that becoming a bigger and bigger part of the market every year. It used to be kind of relegated to, say, space, aerospace, maybe a little bit of medical, where you're coming into these types of materials and processes. But nowadays we see it even in the general market. Bicycles and components for your bicycle and all kinds of stuff is being made out of these crazy materials. So, long story short, we've done a lot recently as far as our pressing technology. I wanted to talk a little bit about, when an insert is pressed, think of any kind of die and mold situation. There's typically a flashing that's produced around the seam of those two units that come together and press that, and that's how inserts are made too. And in the past, the industry standard for that created a lot of flashing, and actually in a place on the insert that's not very advantageous. It was right on the cutting edge where this flashing would occur. And because of that, we would have to peripheral grind these inserts, or even put them through a brushing process or some type of edge honing process before they could get coated. It added an extra layer of complexity to the processing, to the manufacturing, and it also added an extra layer of cost. Since then, we've come up with new ways to press inserts that are pretty fantastic. And in fact, it avoids the flashing all the way together. We can typically go straight to being sintered and coated. We can avoid a peripheral grind operation on these inserts and still achieve either the same results as we would with a ground insert edge, or better results even. So that's been a big thing that we look at. This is a process security improvement. It's a productivity improvement, and it's also a sustainability improvement, because we've lowered the cost of this. We've made it more attainable to do it the right way, basically. Along those lines is coatings. We do a lot with coatings. We've created new coating technologies where we can now do multi-layer PVD coatings, which used to be impossible. On top of that, we actually have processes for that coating that aligns the molecular layers in alignment with each other. And when that happens, the strength of that coating becomes even more durable. So definitely we've got a lot of scientists. We've got a lot of, I call them the mad scientists, but they do a lot of great stuff, and they keep us at the forefront of providing these great solutions to our customers. So, yeah.
Now, to take a quick step back, I wrote this down and I skipped over it. I was always taught that carbide inserts are very rarely ever sharp, or inserts, end mills, are ever completely honed sharp. Carbide was always meant to, I guess they say, rub or shear away material. So without giving up any ghosts, how do you guys get them honed, razor sharp, and still maintain an edge?
Right. So a lot of it comes down to the actual geometry, right? So we're getting into relief angles and secondary relief angles in a lot of cases, and think of that as the foundation that backs up the cutting edge. So that has a lot to do with it. You're absolutely right. If you grind or hone an edge to a perfect sharp margin, oh my goodness, is it not going to last very long, right?
Correct.
We need some kind of roundness to that edge, and a lot of that really depends on the material that we're going to be cutting too. So, and this is where a lot of the challenges actually come in too, because if you're cutting a titanium or a high nickel content or some of these really sticky stainless steels, the sharper the edge, the better. But it's also that backside that's going to get you. The sharper the edge, the quicker it's going to break down, right?
Right. There's always a balance.
There's always a balance there, and so we don't. It's such a requirement on some of these inserts to have that honed edge, between a very, very, very tight tolerance. Those require brushing operations still, or some type of peripheral grind. So if you're going to cut aluminum, or if you're going to cut a really gummy titanium, you're probably still going to need a peripherally ground insert, something that's got a real precision control on how sharp that edge is. But yeah, that is the balance. That's the crux of the matter, is how sharp can you make that edge without it deteriorating too quickly. And then going back to our heat treat material training here, a lot of how you can control how that sharp edge lasts is how you gingerly apply it to the cutting material, to the material being cut, right? Light radial engagements helps with the entering angle of how that tool sweeps into the cut. Whereas if it's, if you're doing a full radial engagement and the tool's moving forward, you've got the insert coming across, it creates a thin chip, it gets to a thick chip, and then it exits out as a thin chip. And those thin chip zones are where no sharp edge is going to hold up, because it's just pumping heat into the edge, basically.
Yep.
And so a lot of it just comes down to the application too. So cutting tool material is important. Cutting tool geometry is important. We can't forget the application strategy is also just as important too. So.
Excellent. Now, you and I talked about this briefly, but and I realize if you can't name drop, that's okay. There's always proprietary things. Is there a specific application or a part or a development that really tested your skills or Sandvik skills to come up with a solution?
Oh, you betcha. I could think of a bunch, especially in the position I'm in as the advanced production specialist. We see everything that's challenging for sure. So we get the call when it's the most challenging. But while I was in sales, I had a customer. They had a series of components. We're talking high complexity components made out of all the nastiest materials like Inconels and Waspaloys and titaniums. And these components got assembled into another major component. And that major component, they were producing one per month. And they had a requirement to produce one per day. And it just sounds completely insane, And it wasn't just the tooling from Sandvik that got them there. And that's the point I want to make. This was a massive coordinated effort between machine tool builders, fixture design engineers from outside of that particular company, the customer themselves. I had a whole team of specialists as well there to help pull this feat off, because it was a lot of different things, basically, with, at the end of the day, the cutting tools and the parameters and the strategies, how we run those, being a big part of it as well. But long story short, yeah, we achieved it. It was a hell of a success. And it was one hell of an accomplishment. It felt really good to get that done for our customer. Our customer was extremely thankful for it, and it helped them achieve all of their goals that they want to achieve as well. So,
excellent. I'd like to wrap the show up today with opening the stage up to you, John and Sandvik. If there are any new developments that you're at liberty to share, any new cutting tools that you're at liberty to advertise, or any way to just plug Sandvik a little bit more to those who may not know who you are.
Well, we're always coming up with new tool concepts and new designs and improvements to existing designs and stuff like that. And so I wanted to take a minute to just talk about our website. You can find a lot of that there. You could find actually so much more than just cutting tools there too. I wanted to briefly talk about how you can find knowledge, basically. So if, let's say you have to produce a blisk for a turbine engine, we have under our knowledge tab, we have sections that will teach you that. They'll go over our industry solutions that we're able to share. and help you get a good start on that. But so much more than that. Going back to these new tools that get released, we spend a ton of engineering and development time on developing these new tools. We release them approximately every 6 months. This is typically in the spring and in the fall. So around the beginning of March and the beginning of September, we'll have major product releases. If you go to our website after that time, you'll find those usually under a link that says, let's see what's new, or latest solutions. Look around a little bit, and that'll bring you to a page that shows you all the new tools that we've developed. Sometimes it's just new grades or new geometries that we've added to an existing line, but in either case, you'll find all of that there. With that being said, there's also smaller releases that come out the 3 months in between those major releases, and those will also be posted online. But if you have a Sandvik rep in your area, and most of us do, they're an excellent resource for that. Internally, we talk about all the new tools that are coming. We prepare our sales force to know what's coming down the pipe, basically. So they have a general awareness, and sometimes in other cases, they have even more than just general awareness. And they'd be at liberty in a one-on-one conversation to tell you really what's coming down. Of course, we're about a month away from a major release, and I'm not at the liberty to announce anything that we're coming out with, but you'll see it with our coral packs when we release them here in the beginning. So
very cool. So as a little service to Sandvik Coromant, in the video description of today, you'll see the website, the general website for Sandvik, and if you follow John's instructions on where to find the information, it's a pretty easy site to navigate. So once again, John, I really want to take a minute to thank you and thank Sandvik Coromant for taking the time to join us on the show today. It's been very, very helpful, very insightful.
Well, thank you, Robert. It's been our pleasure, and looking forward to another one, maybe.
If you guys do a lot of turning inserts, I have a big turning month coming up. I'd be really happy to reach out to you again and have you back on.
You betcha. Yeah, let's coordinate that.
All right, John, again, thank you. For those of you looking for cutting tools, Sandvik Coromant is the place to find some of the best. So once again, we'd like to thank Cutting Tool Engineering Magazine. We'd like to thank you for coming on. And once again, thanks for joining the show. We hope you guys enjoyed it. Make sure you tune in, same time, same place next week, 9:45 a.m. We will have another guest on. So with that, bye-bye.
Thanks, everybody. Bye-bye.